Hello, I'm Robin and welcome to a Molten Modular DIY. Today we're looking at the Apollo View rabbit hole. Interesting thing about the rabbit hole, it's a dirty great big tube that sticks out the front. It's a mixer, VCA, saturator, tube, distortion kind of module. It's fantastically laid out with this red glow that comes from beneath there somewhere. And of course we all appreciate the Alice in Wonderland kind of vibe, kind of connection that's going on, which suggests that there's perhaps a little bit of craziness involved, a little bit of madness. And it's certainly mad in the shed this morning because it's freezing flipping cold. So I'm going to be warming myself with my soldering iron in order to attempt this. Now, as a kit, this is mostly about the hardware, because on the actual PCBs, a lot of it is surface mount, and that's already done. So you've got a whole bunch of caps and chips and bits and pieces, resistors and stuff on here. So this is not going to be a resistor fest. This is all about the mech. It's all about the hardware, the patch sockets and bits and pieces. So I don't anticipate it being too difficult. But also perhaps it's not going to be a traditional, straightforward resistors, diodes, capacitors type build. It might be different. I don't know. We'll have a look at the manual in a minute. But if I get this done nice and quickly, as the kit suggests they may, then we'll also have a tackle on the Curioso, which is the expansion module for this, which gives it a couple of extra inputs. So interesting. I mean, the thing with the thing sticking out the front, I mean, that's really fascinating, because in all the pictures you have of it, like the one here, you have no sense that there's this enormous thing sticking out the front, which is going to be this. Look at the state of that chubby thing. Oh yes, goodness gracious, how interesting. Yeah, I'm probably not supposed to touch it, so I'll just put that down over there and we'll worry about that in a little while. So let's just dive straight in. Let's have a look at the manual. Let's see how they're suggesting that you build it. The manual's available at thonk.co.uk. The kit also came from Thonk. Thank you very much for that. So the way this will work, I'm not going to leave this running live. We'll do some stuff together, we'll talk about it, and then for the soldering, I'll time-lapse that, add a little bit of music in the background so we can all sit back and enjoy the super fast soldering that happens after that. It just depends really. If it's interesting, I'll film it. If not, we'll time-lapse it. I don't mean that soldering's not interesting, because the soldering that I do is always fascinating. That's not my point. The point is that you just want to keep the video into some kind of sensible length. So for now, let's have a look in. You can get the manual from, as I say, from thonk.co.uk if you want to have a look along. But we're just going to take you through the instructions and just do what it says. That's ultimately what we're trying to do. We're trying to assess whether the build guide works, how easy it is to build the thing, and then how awesome a module is afterwards. I mean, we can't already know it's going to be flipping amazing. Anyway, so this module gets loud, it says. It's capable of producing 24 VPPs, or whatever the heck that is. Total maximum gain of over 1,000. It's just 1,000 big. So that's quite exciting. So always make sure things are turned down before you use it. Great, okay. And the minimum output is at the 12 o'clock position. That's good to know, because it's an attenuverter. Right, got it. There's lots of special thanks and introduction, origin type things. Look, Mum, No Computer, apparently it was an inspiration for this, which is cool and interesting. I'm just going to sort of skip through all of that sort of business. It's an expandable audio mixer, great for a drum mix, they suggest, which is probably how I may envisage myself using it. So it could be a VCA to a synth voice. Also adds subtle warmth and character, or total audio destruction. Good. Self-oscillates. Oh, my word. So, essentials. Tools, it says. Soldering iron. Yep, I'm going to turn mine on. And see how that goes. Soldering iron, blah, 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 blah. When soldering pots and jacks, 370 degrees is best. For everything else, 340, it suggests. I'm currently running mine at more like 400. Because that's been working for me, but I'm always open to suggestions. The other thing I did if you're an avid follower, is that I've changed the tip, which is very exciting. I worked out how to do that. You just kind of take it apart and it all falls off, and then you put the other one in. Do it up nice and tight, and that has actually really helped. Now, I don't know, I mean, I'm not an electrical engineer or anything. I mean, maybe I'm supposed to do more about cleaning the end of the soldering iron and that kind of thing, but I've been having some trouble with it. It wasn't really working, wasn't melting very well. Maybe that's why I've had it up so high. And so anyway, I accidentally ordered a new tip for it a couple of years ago because it was on my Amazon wish list, and then somebody bought it for me like as a birthday present, thinking that would be really cool, and it's like the end of a soldering iron. Anyway, I put the new tip on and it just seems to be working brilliantly. So I think in that regard I'm going to turn this down, if I can remember how, just a little bit to 370. I think that would be good. Okay, so solder, they suggest 0.6. I've got 0.7. That's what I tend to use. We use a lead free. Oh, that's interesting. Lead is easier for beginners. Oh, cheers. I like to use lead. I just think it melts nicer. Try not to lick your fingers. A voltmeter, yeah. For calibrating the mix and tone controls, calibration, not my favourite thing. That's always frustrating and interesting, so looking forward to that at the end. Solder mat, I mean, this is not a solder mat, it's an anti-static mat, and I don't even have it plugged into anything. This is an illusion of competency is what this mat is. That's all it is. But hey, it's working for me. Some nut drivers. Not sure what that is. Banana nut driver. I don't have any of those things. I tend to put on nuts with my fingers. I hope that's okay. A flux pen. Oh, I do have one of those somewhere. A cleaning brush. An old toothbrush will do. Yeah, no, we're not going to be doing any of that. Side cutters, I think that's what these are. Pliers and a solder sucker. Yeah, cool. Yeah, good. Yeah, optional masking tape. All right, jumper wire for calibration. Oh, we'll see. And a crocodile clip. We will see. So they're not going to tell us about how to solder. They're just going to show us what we do. So parts list. We should probably go through this to make sure we have everything. So we have the faceplate. Oh, and we have a couple of stickers. Good. Let's just put all those to one side for a minute because they're not essential. Front and back PCBs. Sadly, I have to interrupt at this moment just to say that I completely forgot to turn on the overhead camera for the beginning of this video. So all the bits of showing you all the components and the first bits of soldering are completely lost, which is very sad. But I recovered, and you'll see that later on that we will get stuck into seeing things overhead. So apologies for not being able to see the close-up work to start with, but we'll get there. All right, off you go. I don't know which is which yet. I guess this looks like the back one because that's what the valve will sit into, whereas this is probably the front one because this seems to have pots and stuff on it. So that's probably how that works, I should think. The tube socket. Well, heck, everything's going to be in this neck bag, isn't it? Let's have a look. Power cable to one side, so there's some knobs, put those over there. So there's the socket, tube socket. Trimmers here, I've got two trimmers, one with a side. They've both got side adjustments, two of. Yep. And two trimmers with a top nut. Yep, got those. Two poly capacitors. These things here. So I've got two 8.2 and two 68, so a couple of capacitors to put in. Interesting. Standoffs. Look like standoffs in there. Standoff screws, yeah. And then pins and sockets. Looks like that's two put together. Yeah, see how that's coming apart. So that's probably the 17, and then that's the 11. Straight shrouded power header. Yeah. Expander connection pins. It's probably these. 2 times 3. 2 of. Yeah. 8 thonky conk jacks. 1, 2, 3, 4, 5, 6, 7, 8. 8 banana nuts. I think that's all those in here. I reckon they're probably about right. Knobs 7. Oh yeah, 1, 2, 3, 4, 5, 6, 7. All the same. B100. 1, 2, 3, 4, 5, 6. Tool trimmers. Yeah, that's what they are. So these are your Song Hui tool trimmers. 6 of. B100Ks. I should have Alpha 100s, which are 1, 2, 3. Those 3. 2 of the B100s. An A500 and a B500. Okay, good. Some switches. Yeah, got some switches in here. 2 and a 1. Yeah, and a power cable. Good. I think that's everything that we need. So it says when instructed to solder things in place, it's also implied to cut off the legs of the components. This is only capacitors and trimmers. Once the legs are cut, you can apply heat again to make an aesthetically pleasing solder joint. Do people do that? Do people worry and come back and make aesthetically pleasing solder joints? That's interesting. They've evidently not come across me before. Okay, so front faceplate is that bit. Front and rear with a nice smiley face on it. Cheshire Cat, it's quite gorgeous that, I have to say. And then this is the back. So find the front one, which is this, and you're going to go straight for the power header. Now, normally, as you know, when you're doing a build with resistors and diodes and bits and pieces, you tend to go from the lowest component and build up, because it's then easier to turn things over and to solder. Now, because all of that sort of stuff has been done, I'm just going to do what it says and see how much trouble that gets us into. So I'm not going to try to second guess it. I'm just going to follow the instructions. I mean, they're good. I mean, I have to say that the photos are excellent so far, and this is obviously the first bit, but the fact that there is a photograph and it's showing me what to do is phenomenal. I like that. So the first thing we have to do is put this into that hole there. Now the gap is, they're saying, is forward. So ensure that the key slot is towards the bottom of the PCB, flip it over and solder in place. Alright, easy. So I could probably do with a bit of foam or something to use as a bit of ballast. So that I can put this down without it all just falling out. Like so. So let's make myself comfortable, get some bit of room there. Now there are lots of surface mount around here, so I have the potential of really messing this up if I'm not careful. So let's be careful. Let's bring this in a little bit so I can see. Soldering here. I'm going to get my safety specs and my magnifiers because I can't see anything anymore. Can you see? I can't see anything. And let's do this first bit of soldering together, shall we? So soldering iron should be alright. It's nice and lovely and clean. Bit of solder. I'm just going to solder that first leg, which I can't get to because this is kind of all round the wrong way. So I reorientate myself. Let's go for this corner here. The interesting thing about this new solder iron tip is that it's got this flat end. And is that good or bad? I have not yet quite decided. All I know is that it's working nicely. Or at least it was when I built my molten motion meter. I see that goes on there really nice. I'm just going to hold everything down, give it a chance to cool. And check that it's not wonky. See that? Yeah, that went on all right. I can now solder the rest. So a bit of air to blow away the fumes is a good idea. Now getting in here amongst the surface mount. Oh, that's just going straight on the iron. Come on. See, look in there. There's a bent pin. That's no bleeding good, is it? It's not going to get me where I need to go. Okay, that's better. Right, next, attach the standoffs. Right, so the standoffs are in this bag here. So we've got these little weenie standoffs. Let's take those. A couple of screws. So attach the standoffs to the rear of the front PCB with 2 empty screws. Put the other two to side for now. So this is on the same side as the power header. Again, I'm appreciative of the photograph, and it just goes through that hole. Okay, next take the back PCB, so the other one, and place capacitors on the face. So the face is on this side up. Capacitors, that's these ones. The 268 on the top two footprints and the 282s on the bottom. So we're talking about these fellas here. So if we're looking at this, 68's at the top, the other two at the bottom. So there's this section here. They don't appear to be polarized, these are just straightforward. So I put the 68s, 683J100 there, next one beneath it, and then these two white ones, the AN2K. Okay, I'm going to just bend these a little bit. Now those are difficult to bend because they've got short stubby legs. So I'm just going to give them a little bit. Place the 2x3 headers in the footprints at the back of the PCB. Okay, so it's failed to say that that you should solder the capacitors. I was assuming we were doing a few things there and then soldering stuff together, but no, we need to solder those. It hasn't talked about them, so I'm just going to turn them over like that. That should be fine for soldering. So yeah, solder the capacitors, why don't you? It does look like we're going to be doing this whole thing in completely filmed because it's not as if I have to sit around and do 100 resistors or anything. That one hit me square in the chin. Okay, that's fine. So now onto these headers that go in the corners, but they go this way round. Now what I can't quite see is whether it's big one up or little one up. Is it just like that? Or is it that way round? Connection from Curiouser. Now I'm going to assume, place the 2x3 pin headers in the footprints at the rear of the back. Flip and solder them in place. Suggesting these are a flux pen. I'm not too worried about that at the moment. What I am worried about is which way up these go. Now, because this is the back of the board and these are for connections to something else, your connecting ribbon or whatever jumper is usually on the longer side. That makes sense. You usually solder the shorter leg, I think. I think so. So they're saying put some masking tape on so you can turn it over. See, look at the state of that. That's not clean. Yeah, all right. So in order to do these, what am I going to do? So I want something like that. Because I can't be arsed with masking tape, I'm just going to put something flat on like that and turn it over. And that should all be fine. And I will solder that like so. So, as usual, I'll do a leg and check, and then do the rest. Yeah, look good. Do the rest. Yeah, still getting the hang of this flat-edged soldering iron. But I think that's working quite well. Those are relatively straight. Good job. Next, place the tube socket on the front. This is the tube socket here. So I guess that can only go in one way round, like that. Flip the board and solder. Try to ensure the socket is as level as possible. Okay, so the problem we've got a little bit is that the height, this is a little bit taller than everything else. So how do you ensure that it's flat? Don't know. Just put that down like that and see what happens. Because you've got a little bit of give in every direction. So I'm going to use my magic foam just on the edge here to try to give it a little bit. That's a little bit too much. But ultimately you're going to want to solder it and hold it down so that it is as flat as possible. So what we'll do one leg. Any leg. Quite a big hole. So this is going to be quite a lot of solder to maintain, to enable you to manipulate it a little bit. So you don't want it to rock too much. Okay, so that's a lot of solder going into these legs. Now I'm going to keep it hot and hold this down firmly until it solidifies, and hopefully that will be as flat as humanly possible. It's a bit movie. Interesting. I think that worked all right. Let's do another one on the far side, perhaps. Again, I want to keep it flat if I can. That's a lot more rigid now. Good, right. Continue on. Excellent. That looks all right to me. That looks all right. Next, select the two side adjustment trimmers. Side adjustments. These ones here. And they go in over here. So not the top, the side adjustments, that's what these are. And they go in there. Place them on the face of the back piece of piece so they just move outermost. Flip the board and solder using masking tape if you need to. Well, you can just push those outer legs out a little bit and that will hold them in. Just like that, you see. And put those down. Again, a little bit of foam is coming in handy just for keeping stuff steady. Right, back onto this board, smiley board, and we're putting in these headers. So lay it down, lay the headers onto the rear, don't solder yet. So it appears to be this way up, like so, and this one over here. So locate the top trimmers, which are these. Place them into the rear on the front with the trimmer at the bottom. Don't solder yet. Okay. These pictures are excellent, without any doubt. The photographs are just the best thing to do. I mean, there's many ways to do a build document and a PCB. You could have everything labelled on the PCB, which is very common, and you can do it like that. Absolutely, I've done plenty of kits like that, and it works fine. But having the reassurance of a photograph is awesome. You know, you're following the instructions. It's not, you don't have that sense of anxiety that you have when you're just dealing with a bill of materials and a PCB, where you're, is that right? Is this the right one? Have I got that right? The right way up? You know, that kind of thing. This level of detail in the build guide is just brilliant, totally brilliant. So now I've got those all in there wobbling about. Don't solder yet, it says. So very sadly, it turns out that my overhead camera was not on. That's frustrating. So I did some lovely soldering, which you've only been able to appreciate from a distance, which hasn't made for a particularly fascinating video. But hey, let's continue on from this point, and I'll just show you what we've done so far close up on this camera. So on here we soldered on these capacitors underneath, top two there, bottom two here. Those are the 63s, these are the 8.2s. We soldered on the nice big socket, took some good chunk of solder underneath there. We soldered on these pin headers here with the long bits sticking up, as you can see. And then we soldered on these side trimmers here. So we've built this up a little bit, not too much. Gosh, that's a little wonky. But never mind. On this one we soldered the power socket, and that's been about it. We put the standoffs on, and now we're about to go through this process of putting these bits on and the trimmers. So these are complete. They've got the headers and sockets all in together for you, and these drop with the spiky bits down into this plate here, 17 here, 11 here, next to the headers, and the trimmers also go down through there. Then you need to take the other plate, turn that over, and locate these down so that the trimmers poke through the holes. It's fiddly, but not a major problem. To get that right. So I think those are in. They will bend up if you're not careful. So what you do at this point is you put the little screws in order to hold the two plates together. Now I imagine this is going to come apart at some point soon, so that you can do the other soldering of all the hardware on the back of the front PCB. So that's going to hold that together, so it's no longer going to twang about the place. Because we've got all this hardware to put on, we're going to have to solder it from underneath, one imagines. So this will probably come apart. But this is purely for soldering these bits on here, these bits on here, and the legs of the trimmers here. Now it says that once you're in place, before you solder it, just pull them. So what you do is you pull it out flush and bend it so that it holds it in place, because you don't want them to drop through. You want them to be held nice and firmly. So now we are ready to solder all these bits there, and this side too, and here I believe. Let me just check. Solder the pin headers and solders the trimmers in place, and then you unscrew them and all those things will be fixed, which is great. So this is one of those occasions. This is why I discovered that my camera wasn't on, because I went to turn it off in order to do this bit as a time lapse. And so I'll do these, I'll solder them, and we'll come back and talk about it in a minute. There, that's all done. One note is just that you've kind of got this square, this rectangle filled with all the headers along here, and then this lone one by itself, and I missed it on both of those for some reason, but it still absolutely needs to be soldered, so just be careful you don't miss that particular one. You need to get these little legs off. And now we have to unscrew them to separate them off again. And then carefully prise them apart like that. Totally brilliant, totally brilliant. Look at that, lovely. Okay, now we're going to populate the face side of the front PCB. So the front PCB is this one. I'm going to stick all the stuff on it. Don't solder anything until the face plate is on. Right. So essentially we're going to populate the whole thing, stick all the knobs on, and then we'll put the face plate on before we solder them. So you've got to start off onto one side with the A100Ks. There should be 3 of A100Ks. These fellas here, and they go. See, it's brilliantly done. Look at this. Look at this. It's all just on there, which is excellent. Excellent. Shows you exactly where everything should be going. So let's not get it wrong. So A100Ks, yeah. So little 3 legs, and then you have to sort of give it a little bit of welly to get those lugs into the holes. Oh no, see, that went wrong. Look what I did. Look what I did. Oh, he didn't. Yeah, flipping did. I just bent that leg like a good one. Trying to straighten that out again. Great start. So get those 3 in there. There, much better. Sort of snaps in. Maybe try to get the 3 legs in first, and then push on those lugs, which are probably going to be just that little bit wide, in which case squeeze them in a little bit. Better. And this third one, 2 at the top, is down here. That. Then the B100s, of which there are 2. Those are the mix and tone controls, which is these 2 here. B100Ks. They go in this bottom corner. No, I did it again. Oh my goodness me. Come on. Because you're pushing quite hard to get those lugs in, you can, if you haven't got those bits through first, you can go a bit wrong. There we go. Flipping it. I don't usually have to squeeze the legs in quite like that. So that's quite interesting how perhaps the holes for the lugs are a little bit close to each other. So the B500 for the tube control, that's the B500, is that one. That goes over here. Better. And then the A500 is this last hole here. A500 says on the back. Super. Now place all the tool pots, which will run along the bottom here. Alrighty, so that's these. That's all this lot. They're slightly better, he says. Yeah. Lovely. Looking chunky now. Then you want the Thonky jacks, Thonky Con jacks. To these fellas. So you've got like 2 legs and a third leg. Now, third leg is the one that stick out here. So what you do is you kind of push it into that hole and then rest it in, and it sort of has the effect of kind of holding it in there. Now, some of these are going to share that hole. So for instance, this one is going to use that same hole as that one, and those one in the middle are going to use that same hole. It's kind of like the earth leg. Well, it's not kind of like it. It is the earth leg. And so that's okay that those are connected into the same hole. They don't have to have their own one. Lovely, lovely, lovely. I'm placing in fact, it tells you all about that in the manual, which is great. It's good having that level of reassurance, because it would seem weird otherwise. So that's great that they've got that in there. Screw a nut onto the switches. Wow, there's a lot of stuff going on here. And then stick those on. Oh, look, there's some more thonky conks at the top that I didn't mention. So you should have 2 spares here, which should go at the top here. Slight oversight there in the old manual. So those 2 in. Then we've got these switches. If I put that down, is that all going to... No, it's good. It's sitting on its headers, so that's fine. So we've got 2 switches. Got a big chunky one and 2 less chunky ones. Screw a nut onto them. Okay. So this gets them at the right height, essentially, for the front panel. Okay, that's all on. That appears to be on. Screw a nut onto each. Place with the flat key on the thread barrel of the switch at the bottom. Oh, okay. So on the screw thread, one side is flat. So place switches down the bottom with the flat bit going towards the bottom. So these are going down here. There's a 2 here and 2 here. So you want the flat bit go towards the bottom, which is like that. And this one, flat bit towards the bottom, like that. And this bit, flat bit towards the bottom, like so. Wow. Right, we've got the whole thing populated. Place on the faceplate. This is going to somehow go on here, and it's all going to just poke through those holes bloody perfectly. Come on. Yes, look at that. It flipping did as well. Kinda. Yep, yep. Ooh. So all the bits through on every bit. Those switches can be tricky. Switches should all be in the up position. Well, luckily they sort of were. Hold it on firmly. Check the rear of the front PCB. Sure all the legs are all through the holes. Well, heck, I think so. Take care that all the jack ground pins are through. There's these springy little legs. They're all through. Yeah, yeah. put black hex nuts on first. Place them with the smooth rounded side down. If you position them with a flatter side down, they will scratch while tightening. Washers aren't necessary, but can be used if desired. Finger tight, and then the banana nuts, and then you're ready to solder. Right, so these little nuts here, you've got to get it the right way around. So you want the rounded side down, which is interesting. I guess knobs are going over the top, so it's not going to see anything in particular. So you kind of want these finger tight so that they don't pull the component off the board. Instead, we're trying to sort of secure the front panel down onto the PCB. That makes sense. And the thing is, we seem to be putting the whole lot on. Is that what we want to be doing? I just feel that, are we not going to be taking this off? Are we not taking this off at any point? No, I don't think we are. Okay. But it assumes, this is the slight thing at this point, is that when you start putting things on very securely, is it means you can't really undo it if it's all pear-shaped and all wrong and you're having to resolder and doing everything else during the testing stage. So it's risky, but also, heck, this is going to work. This is going to work fine. Of course it is. And if not, well, you can always unscrew everything. I don't have a hex tool or whatever it is required for tightening up these nuts, and mine are all just going to be finger tight. Then the banana nuts, which are these fellas, they go over the jacks. Okay, looking good. Looking good. Putting any screws on the switches. Then position and finger tight the switch nuts. Okay. Now there are some washers, but I'm going to ignore those because I don't think they look very good on the front panel. I'm just going to go with the screws. Screws, I don't know. Nuts. That's the word I'm looking for. Nuts, not screws. Good. Boom, it says you're ready to solder everything in place except leave the Cheshire's cat unsoldered. Those bits there, which are the lugs from that particular knob, because I reckon it looks better. Alright, and it doesn't affect the mechanical properties. Give all solder joints a quick scrub, and then do the tube thing. So let's do the soldering. So that's quite a bit of soldering on the back here, so I will drop to time lapse for that, and I'll see you on the other side. There, looks like a good job, I reckon. Coming together. Got to be nearly there, haven't we? I think. It's looking great. Looking great. So, I mean, one point to make is just that when you're soldering these things, just be careful of these bits of plastic here. If you lean your iron against them, they will melt and it could be a problem. Hopefully you will smell the smell of burning before it gets too bad, but just try to avoid them. So, gently push the tube into the tube socket. Oh, the other board is what we need. This fella here. Here's our tube. So, yeah, let's make sure we get the orientation right. It's not difficult, I don't think. Just sits there and pushes in. How far does it go in? Is it going all the way in? What do we think? I suppose it does. Oh, that's quite a solid push. Look at the state of that. That's ridiculous. That's just ridiculous. But fabulous all at the same time. Gently but firmly, I would say. Screw the back PCB onto the standoffs, as we did earlier. And then put the knobs on. So yeah, we are done. So this is then got to go through there. Ooh. Very satisfying about that. So line up your headers. See if you can get them to wobble in a little bit on both sides. That's not right, is it? That's a bit better. Oh, there you go. That suddenly went in. I've also got to hope that our things here line up, which they do not. This one here, the tone one, is not quite right. So that needs a little bit of help. There we go. There we go. That slid in there nicely. So put the screws in first. That'll tighten everything together. Great. Then put the knobs on, it says. So it says you should position that a little bit, because it is. Funny enough, it was up against the side a little bit. So just giving it a bit of a wiggle gets it a bit more central, which is lovely. Put the knobs on, and then you're ready to calibrate. Good gracious. So with the knobs, I'm going to turn them all the way around to the left. All of them. These look like they're all the same and just go on in one orientation. Go a bit heavy. Yeah, cool. Alright, simple then. You're not having to worry about where they're supposed to go. They just go flat against flat. Push them on. So they can only go one way around. It's just so epic. Look at that thing. It's an epic module. Absolutely epic. Power cable. It's going to only go in one way around with the key, the knobbly bit to the bottom. I remember mine was a little bit bent, wasn't it? So just got to be, make sure that wiggles in there nicely. I don't think that has wiggled in there nicely. Again, does it go further than that? Yeah, a little bit. Okay, so that goes in a little bit further than you kind of think on first push. That looks better. You can see it through here, whether it's actually made it all the way down or not. So that's good. So now I've got to plug this into something and give it a bit of a test and a calibrate. Calibration is page 23, which I will come back to in a minute. Here we are, it's calibration time. Oh, it's the fun bit. You have to fiddle around and faff around with these bits and these bits. But if you want a module to work correctly, then that's kind of what you have to do. So, test number 1 is going to be plugging it in and turning it on and hoping that nothing smokes. That's going to be the first thing. Now it talks about calibration here. It says that there are 2 types of calibration to perform with the trimmers. The first is to calibrate the crossover mixing point for both mix and tone controls. This step requires a voltmeter. The second is to ensure the VCAs are not bleeding any signal through when the gain control is set to a minimum. This requires your ears. It needs to be connected to power and on for calibration, but you need access to the back, so don't screw it in. So this is off. What I'm going to do is plug this in here. Can only go one way round. Just going to set this in here and turn it on. See what happens. Slightly disappointed there's no indication on the module at all to let me know whether it's working or not. There's also no smoke, which is good. Don't know, I was expecting something. Anyway, let's not get ourselves disappointed quite yet. Okay, so the process is made much easier if you use a male to female jumper and wire clip. Well, I've got a male to male. We won't worry about that just yet. The crocodile clip will be used to help connect the tip of the voltmeter probe to the jumper wire. Alright, well, some of this I can do. Well, let's just go through. I've got my voltmeter here. So the crocodile clip will be used to connect the tip of the voltmeter probe to the jumper wire. There are 2 methods for this. 1, attach the crimpable end of the crocodile clip to the probe, or 2, connect the crimpable end of the crocodile clip to the male end of the jumper wire. It is your choice. Not sure what that means at the moment. So, what? The second method means you can use solder to join the jumper wire to the crocodile clip, which isn't a problem as these items are inexpensive. You will see from the following photo that we chose option 1 and soldered the crocodile clip to our multimeter probe. Well, I've got crocodile clips. I think that's all right. They do that a lot. Okay. Right. We are looking to measure minus 0.4 volts with respect to ground for each of the 2 test points, mix and tone. Without the use of jumper wire and crocodile clip, we would need 3 hands to complete the process. 1 hand to hold the probe, 2nd hand to hold the common ground, and the 3rd just to adjust the trimmer. Right, well, what I'm going to do, I mean, call me crazy, but I'm just going to plug this in here, and that ring gives me a ground, like so. That should be all that's required. It says the middle 2 pins of the header give us access to ground. Okay. No, it's not going to quite work, is it? So I'm going to go with what I thought of, which is that for the minute. Position the test probe at the mix test point. What's that, do you think? It's probably this. Does it say? Yes, mix test point. Okay, I've got minus 4.8, and I will need a small screwdriver, and then I need to adjust this till I get minus 0.4. Okay, hang on. Position the test probe at the mix test point. Check the reading. Adjust the tone trimmer until you get minus 4. Oh, that's tricky. Tricky tone. I'm turning it. Nothing is happening. repeat for tone. Okay, so all right, so that's a spelling mistake then, or a typo. So obviously when you're plugging this into mix, you need to move the mix trimmer here, not the tone one as it says. That's a bit weird. So anyway, turning this, it now moves. I'm getting closer to -4. Good. And do the same for the other side. Good. So I don't know what all that soldering crocodile clips business was about. So to get an earth, all you need to do is plug in one of the cables, and you can attach to the sleeve, and that gives you your ground. So you don't have to connect it in here necessarily, unless I've done something terribly wrong, but I don't think I have. And then you do have 2 hands free to do what you need. So VCA bleed calibration. Due to the nature of tolerance between vintage VCAs, integrated circuits, it's possible that there is some bleed from the VCA. Normally this is undetectable. However, at the high gain it's possible. Therefore we need to counteract this with the trimmers. So patch a signal into A low frequency 100 Hz will do, and patch the output so you can hear it. Okay, so from here I think we need to turn it over. Put it in like that. So I'm going to take the output of the Castor and Pollux. Oh, look! Oh, that's fantastic. Oh, that's really nice. I have to say I'm liking that an awful lot. I thought there was going to be something that was supposed to come up. Right, so I'm going to need to be able to hear this. So I've got a cable here that should enable that. Plug that into the out. Turn that down. Okay, patch anything into A. Patch the output so you can hear through your system. Ensure the output attenuator is turned up, which can be either one way or the other. Okay, turn the drive and tube to maximum. Mix knob seems to be fully wet. Oh, here we go. Turn gain A and B to minimum. Make sure these switches are off. Tone should be in the center. Tone. Setting example here. Adjust the trimmer for A so it's fully clockwise. So I've got my nice trimmer tool. So the trimmer nearest here is A. Just A so it's fully clockwise. Don't these things actually go on forever? Well, I don't think that's going any further. Make anti-clockwise adjustments to the trimmer until there's no sound present. Alright, this is not going well. Adjust the trimmer for gain A, indicated below, so it's fully clockwise. It will click when you've hit the end of the travel. If you cannot hear any signal, the calibration of this channel is complete. Skip the remaining steps. Make anti-clockwise adjustments to the trimmer until there is no sound present. Okay. Now do the same for B, I suppose. So now we plug this into B. Go all the way around on this. Don't seem to be getting anything. It says that sometimes you won't get any sound present at all. isn't a problem. Okay, I'm not getting the click that they suggest you get, but I don't often find, I usually find with trimmers that they just go on forever. And you just have to make a decision that you've gone far enough because it's no longer doing anything useful. Right. That should be it. Now you've completed your build. Contact John Mark at Apollo View Modular who will issue you a special DIY serial number. Oh, okay. That's it. You're good to go. Make some filthy sounds. Right, good, right. Lovely. Well, let's just put a couple of things through it and see what happens. Right, so test it out. I've got a bit of a bass line going through channel 1, channel A, and the other side I've got some drums, as you can hear. I've got the gain set to 12 o'clock at the minute. Gain obviously brings a little bit of colour, even though the mix knob is all the way around to the left. Tube and drive don't do anything at the moment because the mix is over to the left. So let's bring the mix up. Tone seems to be giving me a strange something from somewhere. I looked a bit deeper into the noise, which you can still hear in the background. If I move the tone knob, it will just roll it off. So it's definitely coming from here or something. Anyway, I spoke to Apollo View about it and they suggested it may be because there might be a digital module on the same power bus, and that would be creating the interference. So, I mean, I've only got what you can see here, but it turns out that the Castor and Pollux, although it is analog, does have a digital controller. And so, it's probably this which is causing the problem, which I can demonstrate by unplugging it. There. It's gone away. So this was the culprit. Now, that's not to say there's anything wrong with this. In particular, if I was using a proper posh case, you would probably have some kind of power conditioning and separation between analog and digital modules to make sure that sort of thing never happens. It's never happened to me before. It's a new one on me, but I'm very familiar with this sort of interference in terms of laptops, audio interfaces, that kind of thing. And that, to me, is what it seems to be like. It doesn't seem to be with all digital modules. For instance, I've got an Osiris here, which is a digital wavetable module. If I plug that in carefully, yeah, there's no problem there. It may have inbuilt filtering or all sorts of things like that. Who knows? But suffice to say at the moment that the Castor and Pollux is not the one that I want to be testing this with. So instead, I'm going to use this nice TZ oscillator, an analog oscillator from LA67, and I'm going to use that for my demo. So essentially what I've got here is a rabbit hole. I've got the TZ going through a wasp filter. I've got some drums coming in channel A. And the bass line coming in on channel B. I've got the mix fully over. That's all the way off. So I am boosting it a little bit, just with the gain. But I'm going to put the mix fully up and let's just sort of experience what it is that this thing does. So let's stay with the drums to start with. Add a bit of drive. Try a bit of tube. So there you have it, the Apollo View rabbit hole. That's not an in-depth demo. I just run a bit of bass and some drums through it just for the heck of things, turning things up, messing things about. Haven't quite got to the bottom of everything. It's a bit of the VCA stuff going on down here. Otherwise, it's just the craziest, thickest drive and saturation going in there. That's just quite extraordinary. Gluing a mix together, it said, good lord. Good lord, yes. I mean, that's quite phenomenal. But otherwise, as a build, it wasn't difficult. Follow the instructions. It's all mostly the front hardware. Putting that together, there's none of the tricky stuff particularly involved. So straightforward, I would say. And what you end up with is this rather spectacularly gooey module. I'm quite interested now to put the Curiouser in alongside just to see if 4 channels of stuff is better than 2 channels of stuff. There's other things in here too that I haven't quite gotten into, like, there's feedback, and then you can make it self-oscillate and turn into a bit of an oscillator. There's this late switch, I don't have any clue what that does. And the off with a head switch is really good. I mean, but mainly because it's the one that makes the lights come on. Why don't the lights come on normally, and then perhaps more lights with the off with the head? Because without those lights, it's still great and all of that. It's just I really like those lights, and so I'm tempted to have that on all the time, just purely to get that glow, that red stuff come through. That's all. But otherwise, one extraordinary thing. Probably needs a little bit more warming up that I've given it, but I'll try to do a bigger, proper demo of it sometime soon. But certainly this is going to find... where the heck am I going to put it? Find a place. I mean, I really like the idea of it being a little drum submixer, particularly if I can add another couple on there. That could be interesting, because I'm always running out of channels on my little 6-channel Eurorack mixer feedback thing. That might be a good way to use it. I don't know, it's got me thinking now. Anyway, so there you go. I'll hopefully try to do the Curiouser as well very soon, and we can tack that on the end and see how that works together. But for the moment, that's the rabbit hole from Apollo View and Modular. In the meantime, go and make some tunes.